Welcome back to part 2, and I've taken the liberty of graphing the inverse of the decay exponential equation. So we flipped. Instead of that being at 0, 1, it went to 1, 0. Instead of this being at negative 1, 3, we went to 3, negative 1. If you'll notice, the exponential had an asymptote of y equals 0. Now the inverse, the log, has an asymptote at x equals 0. They flipped. They're inverses of one another, right? So now let's take the domain of the logarithmic functions. So the logarithm here of this, or the domain of this growth function, would be from 0, right? 0 to infinity. What about this one? It's the same thing, right? 0 to infinity. But the range now, the y values can be anything on both of them. So now the range is negative infinity to infinity, and negative infinity to infinity. And if you will look back at the exponential in section 3.1, these were flipped. Okay, we have reversed them. We've switched the x's and the y's. All right, the y-intercept will not intersect the y-axis at all, but it has now an x-intercept of 1, whereas the other one had a y-intercept. Right? So again, we have flipped. Is it increasing or decreasing? Well, this one is increasing its growth. That makes sense. You want that to happen, right? So 0 to infinity, it is growing. You're giving me the x values. Here, this, as you remember, you're coming and you're riding it like a roller coaster. You are decreasing for the decay from 0 to infinity. It is decreasing. I'm going to write that down here. Oops, that's a weird looking infinity. That looked more like an 8, didn't it? That's better. All right, so no increasing there, no decreasing here. The asymptote, which we already spoke, that the asymptote is now x equals 0. Okay, x equals 0. And the end behavior. So the limit here, let's look at the growth. The limit as x is approaching negative infinity, here on this side, the left limit, would be what value? As it's approaching negative infinity, it is negative. Right? But it's only approaching, let's see, this shouldn't be a negative infinity right here. This should be a 0. So I'm looking at the graph thinking that's not right. So as it's approaching 0, it is approaching negative infinity. The function is. Here on the right side, as x is approaching infinity, it is also, the function is approaching infinity. As the x is approaching 0, here for the left end, it is approaching positive infinity. And the right side, because it's decaying, right? As x is approaching infinity, it's going to negative infinity. Okay, let's talk about transforming and sliding these logarithm functions around. This should be very common sense to you now, but now we're going to talk about shifting the log functions around. And if you'll notice, I have the x is now here in the logarithm. Okay, so the same parts apply to everything else we've been doing. If we have a plus or minus in the very, very front, okay, that means that we are reflected, top and bottom. Okay, we are over the x-axis. And sometimes it'll be over a different line, but it's reflected top to bottom. This particular plus or minus, remember what that one did? That one reflected left and right over the y-axis. Let's change colors. How about, let's do the ones on the other end. All right, if I have the h that was inside with the x, that was horizontally shifting it, left and right. And remember, that's the one that's kind of reversed. So if it's positive, you moved to the right. No, I mean, if it's positive, you went to the left. I'm sorry, if it was negative, you went to the right. The k, remember the k moved it vertically up and down. If it was positive, it went up. If it was negative, it went down. Change colors again. All these bright colors. Let's do the little c and the a. We've got those down, right? If it's a coefficient in the very front, then we know that it's going to expand it vertically or compress it vertically. And remember, if a is greater than 1 or if a is between 0 and 1, then this expands it vertically and this compresses it vertically. Remember, the c, if it's in with the x, a coefficient right inside the x in the parentheses, then you have it compressing it and expanding it horizontally. So we're going to write that out. And this would be compressing. Remember, this is flipped from the vertical one. And expand horizontally. Okay, we got one more. We have a new one. We have a new one, and that is our b. The b on the exponential was the base. All right, and that was just the base of the exponent. Here, the base, the b, is going to be the base of the log, right? But it's very important because this base here indicates whether it is growth or decay. So if this base is bigger than 1, then you have growth. And if this base is between 0 and 1, you have decay. So when you come to class, we'll play with exponents and logarithms and go back and forth between them. I will see you then.